All right, so we're starting chapter 6, or unit 6, and this is going to be our intro into the trigonometric functions. And we're going to start off with describing what kind of relationship these have. Periodic phenomena is what we run into, and we'll talk more about that. All right, so the quick notes are two variables have a periodic relationship if the output values demonstrate a repeating pattern over equal length input intervals. That simply means for over an interval of x, we see a repeating pattern of y values that come out. And it continues to do that over and over and over and over again. It's not a one-time deal. It continues that over and over. The graph of a periodic relationship is determined by a single cycle. Because the thing repeats over and over again, we can tell everything we really need to know about it by looking at a single cycle, and then we can apply that cycle multiple times over the entire thing. The length of the input interval for one cycle is called the period, which is known as K. So what that means is that if a cycle occurs over 3 values of x, where x is going from 0 to 3, it will have a period of K. And then, so it's going to have one cycle going from 0 to 3. It'll have another cycle of exactly the same y values in exactly the same order going from 3 to 6. And when we talk about that, we can say that f of x plus k is equal to f of x for all k. Because it repeats those exact same y values over and over and over again, and they're all going to be k units apart to get to the next period, we can actually have not only just f of x plus k, but we can have f of x plus nk, where remember when we talked about n, it can be a counter. We can add k one time, we can add k 2 times, we can add k 3 times, over and over and over again, and we're still going to get exactly the same y value we got on that first cycle. And that is true for all values of k. All right, so number 1, the height of the tide in San Diego, California on a particular day can be modeled by the graph shown. The height of the water is measured in feet and time is measured in hours, with t equals 0 corresponding to 12 noon. All right, so here where t equals 0, that's 12 noon. Describe how the water level is changing throughout the day. Well, the water level is starting up here at 7, it's going down here to 1, going up. So we can describe a lot of different things. At noon, the water level is at a high point. 6 hours later, it's at a low point. 6 hours later, it's at a high point again. So it's going to complete a cycle of going from a high point to a low point or a low point to a high point in every 6 hours. It's going to complete an entire cycle in 12 hours. So it's going to get, in 12 hours, it's going to get from highest to lowest and then back up to highest to repeat the cycle all over again. So at noon, the water levels are at the maximum. Six hours later, the water level is at a minimum. By midnight, the water level has reached a maximum again. This cycle continues every 12 hours. All right, so determine the period for the function and interpret your answer in context. Well, the period for this thing, K equals 12 hours. And what that means is that every 12 hours, the pattern of the water level is going to repeat. Now, understand, it doesn't mean that you have to start right here. You can start anywhere and it's going to repeat this exact same way. If I started here and I went over here to 15, notice what happens. I go through that whole cycle right there and I get back to the point, the exact value that I started off with, and I complete the cycle again. All right, so what do you expect the water level to be at t equals 33? Well, there's a couple ways we could go about that, but if we divide, subtract a division of 12, so 33, and we're going to subtract 12 times 2, that's the largest multiple of 12 that will subtract from 23. I'll get this right in a second. 12 times 2, or 33, minus 24, and that's going to leave you with 9. So then all you have to do is you have to just go across, and right there is where your water level is going to be. Your water level is going to be at t equals 33 hours. The water level will be at 4 feet. Sorry, 4 feet. So it's going to be the same as t equals 9, the same as t equals 21, the same as t equals 33. So every time we add 12, we're going to get to that same point again. So now that doesn't mean that that's not going to be the only place that it works. Notice here it's also at 15, but it's not the same place in the cycle. That's what's important. So we're not going to name every place where the level is 4, but we'll be at 9, at 21, plus 12 gives me 33, plus 12 gives me 45, plus 12 gives me 57. So you're going to know where the 4 is going to hit, at least on that side of the period. You're not going to get all of them, because you still got all these that go in there as well, whether it's at 4 feet. But you're going to get all those on that other side. All right, at which time or times is the water level changing the fastest? How do you know? Well, the water level is going to change the fastest where the slope is the steepest. So that's going to be right there, and right there, and right there, and right there. And it's going to decrease the fastest there. It's going to be increasing the fastest there, decreasing the fastest there, increasing the fastest there. So that's going to occur at t equals 3, 9, 15, and 21. And how do we know? The slope is steepest at these points, or these values of t. Probably be better to say these values of t as opposed to these points, simply because you're not naming points. You're actually just naming the t values. So if you wanted to say at 3, 4, at 9, 4, at 15, 4, at 21, 4, then you could say points. But if you're just naming the t's, it may be better to go ahead and just say at these values of t instead, as opposed to the points. All right, now, not only is it steepest, but what do we notice about concavity? Well, here it's going to be concave down, here it's concave up, here it's concave down again, here it's concave up, here it's concave down. So not only is it going to be steepest, but our concavity is going to change as well. So you could also use that as your reasoning. The slope is steepest, and we have a change in concavity. So that could work. That is another way that you could go about it. All right, so there's 6.1, just kind of an intro to the periodic phenomena and how we're going to start looking at things. We need to look at patterns, because periods are formed by how often the same pattern repeats over and over again. We're going to see a lot of that with trig.